Here I just want to prove that the derivative of e to the x is e to the x. So I've got y equals e to the x, and I'm going to use my first principles again. So x1 is x, x2 is x plus h, and the y1 is e to the x, and the y2 is e to the x plus h. Now my gradient is always y2 take away y1 divided by x2 take away x1. So that comes out like this. So I simply take the y2, take away the y1 value. This gives me the derivative, take away x2, take away x1. Straight away you can probably see on the bottom these are going to cancel. On the top I want to think about splitting up this, and that will split up to give me this. So that's just a rule of indices. Now from there, what I'd like to do, starting from this point, I would like to factorize the top part. So I can take the top part there, take out the e to the x, leaving me e to the h, take away 1, all divided by h. So I've come as far as I want to go for the time being, and now I want to consider just this part here. And I want to remember that h has a limit of 0. So if I make this go towards 0, and I make this go towards 0, I want to know what this thing here inside the box I've drawn is going towards. So I've actually drawn a graph here, e to the x minus 1 divided by x, which is the same function as we've got here. And I need to see at 0 what happens. It's 1. So that whole box there is actually going to 1. That means that we can ignore this, that's just 1, and we're left with e to the x. And that's why the derivative of e to the x is simply e to the x.